Welcome everyone. So in this video we're going to talk about functions. So first I'm going to be defining what a function is, then we'll talk about domain and range of a function, then we'll talk about what is the vertical line test and how to use it to determine if a graph is a function or not, and last, the piecewise function. So I'll show you a sketch of a piecewise function. So let's go ahead and start with the definition, and then we'll dive into the next bullet points. So here's what I have for the definition of a function. So you might already know that the function is a rule that is assigned from each input. So the input, we call it set D in this case, to another set Y to a unique value. And we call that value f of x, and that is in Y. Now, the set D is also known as the domain of the function f. Now, what is a domain? So domain is really the set of all allowable inputs for that given function or for that given rule. So let's call it the set of all allowable input for that specific formula. And the set y is what we're going to call it the range of the function f, and these are the all possible outcomes depending on what the domain is. So let's call it the set of all possible outcomes. So let's call it outputs. And we're going to use the notation f of x to represent all the y value. So now that we know the definition and we understand, hopefully we understand what a function is, let me go ahead and show you an example. It will determine the domain and range. So let's go ahead and find the domain and range of this function by simply looking at its graph. So as we all know by now, this is a common function. So the graph of this function, we should know how to graph. It looks something like this. So it passes through 0, 0, because cube root of 0 is 0. And then it gives us nice positive numbers as you plug in positive real numbers. And as you plug in negative real numbers, it also gives you negative real numbers as its output. So the graph also exists on this side. So that's the graph of cube root of x. So just by looking at the graph, we know the domain of this function is all real numbers, so negative infinity to infinity, and range of this function. So now here you're observing the y values. It looks like everything here also are possible outputs. Therefore, range is also negative infinity to infinity. So we want to find what is the domain of this function and what is the range of this function. So again, we need to make sure that whatever we input makes sense for the formula. So if I start with 0 again, 0 is always a nice place to start. If I plug in 0 into this formula, I get f of 0 is equal to 1 minus square root of 0. And square root of 0, we all know that's 0. That will give us 1 minus 0, which is 1. All right. Now, what about if I go to the left of 0? Negative numbers. Let's say negative 2. Arbitrary. Let's pick any negative number. Selecting negative 2, I get 1 minus square root of negative 2. Well, now, this is a trouble. That is not a real number. So because of that, we're going to call this not defined. We get an undefined, well, we get an imaginary number. It's not on the real line, therefore negative numbers are not allowed. So it makes sense to say that these numbers would not be allowed for this formula. So we know the positive numbers make sense, but let's double check it. So if I plug in, let's say, another number into this formula, let's say 4. 4 is a nice one to work with. So we get 1 minus square root of 4. That gives us 1 minus square root of 4 is a 2. That is negative 2. Check. So it makes sense. So we know that from 0, including 0, to infinity would make sense for this formula. Therefore, our domain would be including 0, because 0 makes sense, up to infinity. Now, how about the range? Well, we know we cannot have negative input, but can we have negative outputs? Probably, right? So the lowest value we can get when we plug in 0 is 1. Now, whatever I plug in some more numbers from here on the domain. So let's say we plugged in -2. Sorry, we plugged in 4. So let's suppose this is 4, we got -2. So we got a negative value. And then when you plug in another number, let's say 1, you get f of 1. That's going to be 1 minus square root of 1. That is 0. When you plug in 1, you get 0. And then when you plug in greater than 1, it tends to be negative numbers. So what that means is the domain is 0 to infinity, but the range is going to be including 1. It will be from 1, and then it's just going to go to negative numbers. So negative infinity up to 1. That will be the range. Another way to see this problem will be to just simply looking at its graph, and you'll see that the range is all negative in numbers up to 1. 1 is the highest number we can get for this particular formula. Okay, now let's take a look at the vertical line test. So here's a graph, and we want to determine if this is a function or not. So we have some graph, and we want to draw the vertical line test. So the vertical line test is a way for us to determine if a graph is a function or not. So in order for it to be a function, you must have one input and one output, and that output should be unique. So if I draw the vertical line through this graph, it looks like so over here, I'm fine. It hits the graph only once, so this is good. But if I start sliding that line, the vertical line left and right, I start to hit the graph more than once. So I hit the graph here, here, and here. So if this is some, let's say x equals some a, then there's 3 different outputs. So here you have 3 outputs for x equals just a single value. And therefore, this graph is not a function. So a quick way to determine if a graph is a function or not, but just by simply drawing the vertical line test throughout the graph. And if it hits the graph once, it is a function. If it hits the graph more than once, it's not a function. All right, so that idea should be clear. Let's go ahead and take a look at a piecewise function now. So in order for us to come up with the graph of this given function, we're going to graph each pieces to come up with the g. So first thing you want to do is rewrite the function. So you know g of x is determined by this formula only on the interval 0 to 1. So 1 minus x only on the interval when x is between 0 and 1. And we know 1 minus x is a line, so you should have that in mind. And then we're going to graph the function 2 minus x on the interval when x is between 1 and 2, but including 2, not including 1. So I'm going to go ahead and draw the xy plane. Let's suppose this is our xy plane, and the function only exists within this interval, 0 to 2. So 0 to 1 is one piece, and then 1 to 2 is another piece. That means the domain of this function g is only from 0 to 2. That's where the graph exists. So let's focus on 0 to 1. So the first interval, the first function, we have 0, and let's suppose this is 1 and this is 2. So focus only from 0 to 1. So in this region right here, we're going to draw the function 1 minus x. So I'm going to go ahead and plug in the endpoint 0. So when I plug in 0 into this function, g of 0, this is the notation we're going to use, g. and you get 1 minus 0, which is 1. Now this endpoint is closed because it is equal to, less than or equal to. Equal to means you can include that point in that graph. So when x is 0, we're at 1. Let's suppose this is 1 right here. And then when x is 1, let's evaluate g at 1. That's going to be 1 minus 1, which is 0. Now this endpoint is also closed because of equal to again on the inequality. So when x is 1, we're right here. And I draw the linear line like that. That's my linear function. Now from 1 to 2, that's this interval. Let's figure out what that will look like. So that's another line, 2 minus x. Again, plug in the endpoint. So we're plugging in 1, evaluate g at 1. That would be 2 minus 1, that's 1. Now this endpoint is open. Open because it's strictly less than. So when x is 1, g is at 1. So let's do this one right here, open circle. Now plug in 2 into g. You get 2 minus 2, that's 0. Now this point is closed because of the inequality is equal to on the bottom. So I plug in 2, it's going to be at 0 right here. And again, I make another line because it's a linear function. So there you have the picture. So together, this is our function, g of x. So this is g of x when is 1 minus x between 0 and 1, and 2 minus x between 1 and 2, not including 1. Now, we know the domain is 0 to 2. As you can see, the graph exists only from here to here. So that's the domain. And what about the range then? The range of g, it's the set of y values. So that's going to be the lowest, which is right here, and all the way up to here. So that's the range. So it's only from 0 to 1. So from here to here, that will be the range. So including 0 to 1, again, including because it's included right here. All right, so I hope these illustrations with functions make sense. Of course, there are more ways to represent functions, so stay tuned for that. See you next time.